In this video we're going to be introducing systems of equations. And systems of equations is when you solve more than one equation simultaneously. So we're going to be solving for two equations at once. And there's three different methods to solving systems of equations. The first is graphing, the second is elimination, and the third is substitution. Today we're going to be focusing on graphing. And there's going to be two different videos. One we're going to graph with a graphing software, and the other one we're going to graph manually. Graphing software is by far the easiest way, but we do need to know how to graph them manually because that's what we've been working on building up to this. Okay, if we were going to graph this manually, we would have to first either change the this equation is written in standard form. So we would have to use the x-intercept and the y-intercept and graph the line that way, or we would have to convert it to slope-intercept form. Either way it's fine. But because we're using graphing software, Desmos.com does a really good job of allowing you to enter them in any format. And so you literally just type it in exactly the way you see it. When you are graphing two equations, the entire concept is that where they intersect is the solution. Every two lines intersect in exactly one point, and that one point is what we're looking for. So let's go ahead and graph these two equations, and I'll show you what I'm talking about. If you went out to Desmos.com and you enter the two equations on the left-hand side, they automatically color them in different colors so that you can tell the difference between the two lines. The first one they color-coded red, and the second one they color-coded blue. And you can change the colors if you want, but it doesn't matter. Notice that they intersect, and if you tap on their intersection, it'll show you the value or the coordinate point. And this is actually, we're done. Like, we've found a solution. The solution is right here where they intersect. Notice that x comes first in the coordinate plane, so x is 0.6 and y is 3.6. And that is our solution. It doesn't get much simpler than that. There are some things that we need to go over. It could be possible that there's no solutions, or it could be possible that there are infinitely many solutions. Most of the time, there is one solution, where they intersect at exactly one place. So let's go over that. The one we just did is an example of one solution. They crossed over, they intersected at exactly one point, and we were able to determine what the x was at that point and what the y was at that point. And the only reason we were able to do that is because they had different slopes. If they hadn't, we wouldn't have been able to do that. For example, if the two lines never intersect, like this example, then that means that their slopes are the same. So the lines are parallel because they have the same slope. Anytime that you have the same slope, then you know they're not going to intersect, and you know there's not going to be a solution. Let's just do an example like that. Let's say y equals 4x plus 1 and y equals 4x minus 3. These two equations, immediately you can tell that they have the same slope. They have a slope of 4. Because they have the same slope, they're never going to intersect. They're just going to be very close to this example. One will be up here and the other one will be down here. This is a negative slope, but same concept. They're going to look like the exact same line, only they're going to be on different spots of the graph. If they actually are the same line, meaning when you graph them, it looks like you just graphed one line, one's laying on top of the other, then infinitely many solutions, anything that you can think of, will work for x and work for y. So I'll show you an example, and sometimes it's actually pretty easy to see. Let's say you had an equation that was 2x plus 5, okay? And another equation was 3y equals 6x plus 15. Notice that these two equations are actually the same thing. This one is just everything's being multiplied by 3 because I got 1 here. So 1 times 3 is 3, 2 times 3 is 6, and 5 times 3 is 15. That's actually the exact same line. If we graph these two equations, it would look like we just graphed one line, and that would have infinitely many solutions. Now, most of the time, there's one solution, but the other two are possible, and you need to keep your eye out for them. So let's recap. If they have the same slope, there will be no solution. If they have different slopes and different y-intercepts, then there'll be one solution. If they're actually the same line, then there'll be infinitely many solutions. Okay, so let's do some examples together. And I do want you to use the graphing calculator today and just practice, just getting the concept of a solution down. Some of them might be no solution, some of them might be infinitely many solutions. Let's just do number 1 together first. Looking at number 1, they have different slopes, so I know they're going to intersect. And so that's good. We're going to have one solution here. So I went out to Desmos and I graphed those two equations, and sure enough, they pass over at 6:13. So my solution is x equals 6 and y equals 13. And that truly is the answer. And to prove it to myself, I'm going to show you how to check yourself. So we said that x is 6 and y is 13. So if we plug that in to both, let me get my red. Okay, plus 6. Okay, so if I plug both of the x's in, then both of these answers should be 13 because we said that x is 6 and y is 13. So this should be 13 in both cases. So we're going to check and see if we're right. Is 6 plus 7 13? Yes, it is. So this one's good. All right, let's try this one. 2 times 6 is 12, plus 1, is that 13? And yes, it is. So this is good. So we know that these solutions are right because they work in both equations. They have to work in both equations, or else we've done something wrong and we need to start over. Because we're using a graphing calculator, the odds are we're not going to mess up. But if we were graphing manually, which we will be soon, it's very possible that we're going to mess up because we might not draw a straight line, or it could be a fraction. Fractions are hard to see on a graph. So we just need to know how to check ourselves. Okay, so your assignment for today is to go out to desmos.com. I want you to do the rest of these, so these 3. And I also want you to do this set and this set. Because you're graphing with a calculator, it really is not going to be hard at all. If you have any questions about how to enter the equations on Desmos or how to get to there or anything like that, raise your hand and I'll help you get started.